So this concept of tipping points is an important one and yet a difficult one in the sense that they are not easily predictable. It's not even always very easy to say how close we are to a tipping point, as I said before. So here are the heuristic tipping points that people typically put together. So 9 climate tipping points where rising global temperatures could push parts of the Earth system into irreversible change. So its tipping point just means, if you think about the well and the ball example, you have sometimes perturbation that can make you oscillate, and sometimes you tip over and you are in a new state that is irreversible. And there are examples from the past where things have been seriously enough perturbed that you can say there have been tipping over across some of these thresholds. So let's just look at this, starting, let's say, in the north. So Greenland ice sheet disintegration, irreversible retreat of ice sheet caused by rising temperatures. So sea level rise would be 2 to 7 meters. So you can see the impacts can be quite severe as well. Is Greenland ice sheet going to disintegrate if the CO2 increase and warming continue? That's definitely a possibility. Some projections do say that, but the question is when. If it is 2500, year 2500, then how reliable are these projections? But the sea level rise projection is not very hard to guesstimate, because we know the volume of the glacier that's locked up. If you convert it all to water, you can easily see how much sea level would rise globally as eustatic sea level rise. But of course, dynamics would say the sea level rise would not be uniform. It's not a bathtub, so dynamics would create ups and downs. So those are not that easy to predict. On the other hand, permafrost loss, abrupt increase in emissions of carbon dioxide and methane through thawing of frozen carbon-rich soils would release greenhouse gases and amplify the warming. So that's a positive feedback, and you have large regions of permafrost that are already being perturbed. Atlantic meridional overturning circulation breakdown, shutdown of the AMOC caused by an increased influx of fresh water into the North Atlantic. So this is something that has happened before. Fairly large flux of fresh water occurred around 80 to 150 years ago, and also 11,000 years ago over the so-called Younger Dryas. I have podcasts on that if you want to look up. But as I mentioned before, if Greenland glacier melts very rapidly, for example, and before it gets eustatically distributed, it's going to inundate the Gin seas, Greenland, Iceland, Norwegian seas, and Labrador Sea. That could be serious enough perturbation. That could cause a sea level rise for sure, and also regional cooling. So if you are not taking the heat northward because the meridional overturning circulation collapsed, as long as the Earth is a sphere and is rotating around its axis, the Gulf Stream will not stop. It's a matter of how much heat is being carried by the Gulf Stream northward. So that will change. So that is what we call meridional overturning circulation. So if you don't bring enough heat here, you're going to cool it here, you're going to slow down the sinking further, and you can have these kind of positive feedbacks. So boreal forest shift that we already mentioned, a shift in boreal forests, seeing expansion into tundra to the north and dieback to the south. So it will shift northward. So the southern edge will move north, northern edge will move north. So they will have ecological shifts, and regional warming will be caused because of albedo changes and related effects. Of course, there are details of CO2 changes, precipitation changes, etc. as well. As I mentioned before, vegetation feedbacks can be quite complicated. Amazon rainforest dieback, so deforestation and hotter, drier conditions causing dieback of the rainforest and a shift towards a savanna. This is something that has happened in the Eastern Africa around 3 to 5 million years ago because of natural changes related to the movement of Australia northward, for example. So this would lead to biodiversity loss and decreased rainfall. You also have corals, so you have coral die-off, which can lead to rising temperatures, pushing corals beyond tolerable levels of thermal stress into an alternative state dominated by microalgae. That could lead to serious ecological changes, and these are warm waters with less nutrients, but corals make a huge difference as rainforests and rich recycling systems, as I said. The color code here you can see here, it's melting, biome shift, and circulation change. So here you can have West African monsoon shift, which also has happened just in the Holocene because of orbital forcing. Abrupt change in Sahel rainfall caused by a shift northwards, so wetter, or southwards, drier in West African monsoon. It can shift northward, create wetter climates, or shift southward, create even more drier climate over Sahel. Would lead to serious ecosystem change and perturbation to this global south or developing countries here. There is also Indian monsoon shift. Monsoon system could be weakened by higher aerosol emissions or strengthened by rising CO2 emissions. So aerosols generally do solar dimming, the direct effect as we called before, and also affect the cloud optical properties, cloud microphysics and rainfall amounts, droplet sizes, and so on. This could lead to drought and decreased carrying capacity or food production for one of the most populated countries in the world. Hopefully that will change in the coming decades. What else? West Antarctic ice sheet, obviously we talked about it a little bit. Collapse of the ice sheet triggered by present grounding line retreat that we mentioned in one sector, cascading to other sectors. So if you have serious changes in one sector, it's going to change the circulation, ocean circulation, atmospheric circulation, snowfall rates, and affect in all other regions of Antarctica and Southern Ocean. Expected sea level rise would be 5 meters. Okay, so what else? Did I miss anything else here? Okay, so just remember those things. I will stop this regime shift. As I said, there are papers written that the Indian monsoon is potentially going to collapse, but there are details. For example, if global warming action reduces the aerosols, then the land warming, solar dimming would decrease, land warming would increase because land has lower heat capacity than the ocean, which would increase the thermal gradient from the ocean to the atmosphere to land, and can increase the monsoon. And most of the projections for the future from the models say that monsoon will get stronger, as we saw already in some of the projections we looked at. I don't know if I can add anything else. Let me leave the tipping points there. There are also papers using published projections to make heuristic arguments that we are getting closer to the tipping points. I myself mentioned that Arctic sea ice seems to be getting closer and closer. If the polar amplification and CO2 increase and polar amplification continue, and the ice loss continues, and the ice albedo feedback continues, and there are also associated water vapor cloud feedback changes over the Arctic, it's possible that we would make almost all the sea ice disappear. But when? This is a key question. And as I said, if Arctic ice disappears, not everybody will be sad. There are many countries who are staking a claim to territorial regions in the Arctic because there is massive amounts of fossil fuels buried in there. The question is, can we afford to take those fossil fuels out and burn them? Somebody might say, well, we will be able to capture the carbon and sequester it, so we don't have to worry about it. But there is no viable large-scale carbon capture working right now. There are many ideas around, but the amount of carbon they draw down is tiny bit. I have a geoengineering course where you can learn more about carbon capture and sequestration and what are the various ways in which they are being tried as well. So let's leave the tipping points here and come back and look at some more projections of climate change. Okay.